Hello. Can you hear me? Yeah, OK. So welcome to my session on retrofitting IoT with Arduino and LoRaWAN. My name is Sebastian, as you have heard, and I'm here for Arduino. No. Of course. Bummer, we're not at the tech conference. No, there we go. OK, so I assume a lot of you have an idea of what Arduino is. Otherwise, you would maybe not be sitting here. Well, let's do a quick quiz. So who thinks that this is Arduino? Please raise your hands. OK, yeah, good. Few people. Fantastic, more people. What about this IDE? Anyone? OK, still some. Fantastic. What about the hardware abstraction API? Still some hands? Yes, thank you. OK, you're all correct. I would describe it as an open electronics platform that's based on easy-to-use hardware and software. And that means we have a hardware abstraction layer, so your code works across the different boards. And we have a lot of boards with integrated sensors. We have extension to these boards, namely the carriers and the shields. And we also have developed a cloud infrastructure for IoT purposes. We have a complete development toolchain. And I think what's most exciting is that we have thousands of libraries for any kind of sensor or actuator. And a lot of them have been developed by our fantastic community of over 30 million people. So thank you for that, community. So that's Arduino. But what is retrofitting? It basically means to update an existing system or technology and make it better, so to enhance the functionality, the performance, or the efficiency. And you often do that by adding new components or features to it. In the context of IoT, it means to add Internet of Things functionality to an existing system to add connectivity and enhance the features that way. OK, so let me tell you a personal story in that context. And not too long ago, my wife had a small startup business to sell frozen handmade empanadas, which is a Latin American pastry filled with a variety of savory ingredients. And business was actually going fine. And as the business was picking up, we sort of didn't manage to deal with all these small freezer boxes anymore. So we got ourselves a cold storage room. And as the law wants it, you have to keep your frozen food at minus 18 degrees or colder at all times to not break the cooling chain. And that's roughly what it looked inside. So that's about 7,000 euros of inventory, empanadas and ingredients. And then we got a phone call from one of her part-time employees in the morning, and she said that the display showed minus 3 degrees. Yes, you guessed it. That was not great news. And it turned out that was the case for the whole night, which meant the whole food was spoiled, and we had to get rid of all the food, throw everything away. So that was a huge loss, right? So that was quite devastating. And I told myself that I will look into this. But what happened? So basically, the guys who installed that system, they didn't really do a particularly good job at welding the pipes that go from the evaporator, which is this thing, to the compressor outside. So they destroyed the insulation here, which meant that it had extra heat exchange with the environment, which meant that the compressor had to work harder to do its job, which meant that the evaporator would build up frost on the backside, which then led to the whole system to break down. Now, told myself, I'm not going to let that happen again. So I implemented an IoT solution to remote monitor that system to know what's going on. And it's that little thing here, this box that you see in that rectangle that I implemented. So let's have a look inside. It's very simple, actually. So it's an Arduino. Let me put this up. So it's an Arduino board plus a shield. There's a backup battery in case of a power outage. And then there's a light sensor, which I use to track the light in the room outside. And then on the user side, I use the Arduino IoT remote app that gives you access to dashboards, and I specifically set up a dashboard to give me access to all the properties of that cold storage room. You can also use that to receive notifications. We currently have email notifications, and in-app notifications are coming soon. So that's good, right? But how do you make that? How do you implement that? So I'm going to give you a quick rundown on that. So let's have a look at the requirements. So you need to be able to read the sensor data from the cold storage room. You need to read the alarm values and so on. Then you want to send that data to the cloud. You want to be notified if something is not good, like if an alarm goes off. And then you may also want to be able to inspect the status of that device to read the temperature or the last time it defrosted and so on. And you may also want to trigger some actions, such as turning off components, or in this case, maybe the compressor, or manually start defrosting. That's roughly what the system overall looks like. So the centerpiece is the Arduino cloud. And then you have, on the bottom right, you have the hardware part of it. So there's the controller that comes pre-mounted on the cold storage room. And then I used an Arduino board to read the data from it. And then the cloud part of it is basically to get that data over LoRaWAN to the thing stack, which then forwards it to our Arduino cloud. On the user side, as I said, I use my smartphone, which gives you access to your dashboard, and it allows you to get notifications from the cloud. But why would you want to use LoRaWAN in the first place? Why not just Wi-Fi or cellular? And I tried that. The thing is, in this facility, there are super thick walls, and it didn't work with Wi-Fi, and also cellular was quite difficult. So what I did instead, I used LoRaWAN, which has very good indoor penetration, which can go up to roughly 500 meters inside the building, which was fantastic for that use case. So this Arduino board would read the data and then send it through the walls to the LoRa gateway that I installed in a different location in the building. And that one connects with the Wi-Fi router and sends the data to the thing stack. Also, I got to say that we were not allowed to install Ethernet cables. That would have been another option, but not that time. All right, so that's why LoRaWAN. I opened the box, right? That's what you do if you want to implement something like this. I don't have a background in electronics. And I opened this, it said 400 volts. I was a bit scared, but I'm still alive, as you can see. So I survived, didn't give up. And luckily, I found that label down there near the controller unit. And then I looked at that, and I found something that sounded familiar. So it says here, like Modbus and RS485. Didn't really know much about it, but I heard it before. So I Googled it quickly, and it turns out that we have hardware to connect to it. So namely, I used this Maker 485 shield to read the RS485 signal from the controller. And then I stacked that on top of a Maker WAN board, which you would use to process the Modbus protocol, which is a data protocol, communication protocol, and also to send the data over LoRaWAN. So this is the modem that's on the board. And as I said, I installed a local gateway. You don't have to do this, but if you're lucky, you have some public gateways around. And you also, as you all know, this is like all transparent to the end device. But I wanted that to be rock solid, so I installed the gateway locally. Good. Another scary thing. So I was able to read the data from the controller of that cold storage room. But it's all ones and zeros, right? So what do you do with that? And I read up a bit on the Modbus protocol, and it's actually not all that difficult. So what I wanted to do, I wanted to extract this thing here. I wanted to know if the high temperature alarm was on, and you can do that fairly easily through using an Arduino library. So you just have to query the register 1282, which is described in that data sheet that I found on the internet for that specific controller. And then you need to extract from the lower byte the fourth bit. And then if that one is 1, it means the alarm is on. And to do these bit and byte operations, Arduino has an API for it, so it's really simple to do. All right, so I got that covered. Nice, so I have all the information ready. And as I said, I use the Arduino IoT Cloud, and in general, you can use Arduino Cloud to inspect your hardware status, to read sensor data, to track that sensor data over history. You can even send messages to your maintenance staff, or in our case, if somebody has to go and fix, then they should read that message. And you can trigger actions through buttons and sliders and knobs and so on. So we have a variety of different widgets available. And what's really cool is that we partnered up with the Things Industries to provide you a seamless integration with our cloud. So if you want to use our cloud with a LoRaWAN capable board, you can do that very easily. So you don't have to actually go to the Things stack, set up your application, register the device, provision it, and so on. All of that happens automatically behind the scenes. So you just connect it, you select your region, and you're ready to go. Super cool. Now, to capture the data from that cold storage controller somewhere, we need a data container. And in our infrastructure, we call that a thing. So a thing consists of different properties, variables. For example, I mean, that one is probably the most relevant in our use case, so the ambient temperature. And to set it up, you can either use the UI, as you see here on the right side, or you can use the CLI if you already have a template. And I have just released the library that I use for this project as open source today. I also provide you with the template for it. So if you use the command line tool, it sets it up automatically for you, just one command, and you're ready to go. Same for the dashboards. So you can put together the dashboards with the UI, if you wish. Or again, if somebody gives you a template or you create your own template, you can do the same via the Cloud CLI. So you provide the template and you tell what kind of thing it should connect to. Great. So there's just one more thing to do for our system, which is to set up the notifications. And we just recently announced this feature called Triggers that follows a if-then logic. And in my case, I set it up such that when this variable temperature alarm status changes from false to true, it would send me an alert, it would send me an email. And as I mentioned, soon we're also going to have the in-app notification. But I was not really 100% happy with it yet. I wanted that system to be better. So instead of telling me when things are already on fire, I wanted that to tell me, or to give me a heads up before the things actually break. And this is something called predictive maintenance that you can do, which is you do an early detection. And in my case, I used an Arduino board to measure the vibration of the compressor, but you can also go for the evaporator in this use case. And you train a machine learning model on the normal pattern of vibrations, and then you run it locally, so it doesn't need any internet connection. And when it then detects that something does not fit that pattern, it would it would tell that. So it runs the classification, and it sees something is wrong, and then it tells that to the host board, so the maker-WAN board that sends it over LoRaWAN to the cloud. So again, you have access to that on your dashboard. In this case, I used the Arduino NickleVision, which is one of our pro products. And I did that because it has a very nice operating temperature range of -40 degrees to 85, which is it's nice if you want to use that in a cold storage room. So that's predictive maintenance, and since I already had an Arduino board that has a camera on it, I played around a bit with machine vision, and you can do very cool stuff with that very easily. So I did some basic shelf monitoring, so simple inventory management, and you can do that very easily by, in this case, I just counted the boxes, and I didn't even need machine learning because the boxes consist of these lids, right, the blue lids, and they're stacked on top of each other. So you just process that image and count the blue blobs, and then you know how many boxes are in the shelf. And then again, you send that information to the host board, sends it to the cloud. I did that with OpenMV, which is a machine vision framework from our partner, OpenMV. Good. So then I was waiting for the prime time of that system, And turns out that it worked. So the next time that somebody accidentally left the door open, we received the notification, then we went there, closed the door, and made sure that the goods were safe. And I think what I want to say with that is I did not have any prior experience with all this technology, but Arduino enabled me to quickly learn about that stuff and then use it effectively to do something that I didn't think I could do. And you can do that as well. So I want to leave you with a few links to get you started with this. So some pointers to get started with Arduino if you haven't done that yet, but also here's the link to the library that I released today, and then a link to the predictive maintenance workshop I did last year at the conference. And then last but not least, if you want to do some blob detection, you can follow this tutorial. And so what I did there is literally 30 lines of code. And if you want, you can swing by at our booth, and I'm going to show it to you. So thank you for listening. I'm here for questions.
Thank you very much. Are there any questions?
OK, I have one. If nobody has a question, I have one. So let's get back to this. How would you, if you wanted to count the green boxes instead of the blue ones, anyone has an idea of how you could do that with sort of analyzing the image, the colors? Anyone wants a free Arduino board? No? OK, I'll take it.
Oh, yeah. One moment. I'll bring you the mic.
I think you should try to detect the hand grips, so the rectangle cutouts.
Yes, perfect. So basically, first figure out the overall area, which is green. And then, as you said, inside that area, you can figure out where is it not green, right? And then get that handle and count the handles. Very good. Swing by at the booth. I'll give you some extra merch.
I have another question. I was wondering, I'll go here. I'm impressed by the retrofitting. I think that's really awesome. And I was wondering, you said, OK, the alarm triggered when someone left the door open. Didn't you test before that, or how do you do that?
Obviously, I tested it beforehand, but I mean, it's never the same as the actual incident, right? So then it's when it matters, because when you test in the lab, usually things go fine. Yeah, I think there's some nodding heads, right? So in the lab, everything works fine, but when it's time to work in the field, it's a different story.
Is that also the reason that you want to have like data all the time to check if it's still OK?
I mean, you don't have to check it yourself all the time if you set up these triggers. And the only problem still is when you get that notification, somebody has to go there and do something about it. So at night, I'm not sure who checks their phones. Maybe you shouldn't. But yeah, so that's the idea. So you can also set up to send these notifications to multiple people. Maybe you have somebody who's sort of available 24/7 to take care of that.
Right? Like babies and night shift.
For example, yeah. For example, the parents who are awake 24/7.
Awesome. And you said you looked up some things on the internet. Did you also leverage the community to realize which triggers you should do or how to do this?
It wasn't actually necessary. So all the documentation was available, and I think the challenging part is to sort of, have the confidence to sit down, tell yourself, OK, you can do that, even though it's 400 volts. And then you find that information all available, because it's really well documented. It's easy to do. You just need to find out, how to do it, and then sit down and actually roll up your sleeves and do it.
Yes, and Arduino has a lot of different things, actually. So you work there, but is it difficult to know which particular one you need for this prototype and then, implementation?
I think it's not, in that sense, difficult, but usually you do have a couple of options. So if I were to build this again, I would probably not use the Maker WAN board, but we have now more sophisticated products from the Arduino Pro line, which have a little bit more power. There are more low power also, and you can just process the data faster, and it's a bit more reliable because they are actually made to be used in final applications, so they're pre-certified. As I said, they have a nice operating temperature range. They're resistant to vibration and so on. They are resistant to corrosion. So I think I would use something from the Pro line instead now. But if you have the technology, as I had in this case, it was kind of clear at least the direction that I need to go into.
Awesome. It's like, for me, it looks like puzzling, but then next level puzzling. Is it possible for anyone to do this, or do you need specific knowledge?
Well, I may have had a bit of a head start working at Arduino, but as I said, I have zero background in electronics, and I didn't know anything except of the basic Arduino stuff. So either you already have that in your backpack, or you get it. I will say, I taught classes in Arduino, so within 1 week, the students get up to speed, and they will be able to do something like that, definitely. So I will say anyone can do it.
Awesome. Any more questions? No? Thank you very much.
All right, come by to our booth, and we keep up the conversation. Thank you.